I'm David Tarboton, Director of the Utah Water Research Laboratory. We conduct collaborative water and environmental research to advance innovative solutions, promote scientifically informed policy and management decisions, and train tomorrow's leaders. We are excited to be part of this new global collaboratory looking for solutions to the world's pressing water problems. Utah faces problems that are common across the western US, related to drought, climate change, water demands exceeding supply, water and environmental quality, aging infrastructure, and a developing and urbanizing environment. The Utah Water Research Laboratory conducts research on many of these, following an interdisciplinary and data-driven approach. Solutions to our pressing problems demand integration of information from multiple sources. There's thus considerable emphasis on data and information systems, and the hydroinformatics involved in data sharing and data organization. Innovation and technology advances are needed to address the information science challenge of collecting, organizing, and integrating data from multiple sources to produce information that is consistent, reliable, and ready to use. To be specific, I'm going to focus on the Great Salt Lake, as it is a pressing local challenge that serves as an example for broader, regional, and even global challenges. In 2022, the Great Salt Lake hit a record low level due to both decades-long drought and water use. In the Great Salt Lake Basin, consumptive water use is more than half of the natural flow. Since the Great Salt Lake is a terminal lake with evaporation the only outflow, it is not surprising that it is adjusted by shrinking to halve its area. The shrinking lake is having severe impacts. Exposed lakebed containing toxins is generating dust, impacting air quality in the Wasatch Front metropolitan area, where millions of people live. Great Salt Lake mineral industries are being impacted by lack of water, and the high salinity is impacting the production of brine shrimp, an important part of the world's food supply. The ecosystem involving migratory birds is also severely affected. Saving and restoring the lake requires a multidisciplinary approach. It requires measurements, data, and modeling to comprehensively quantify what is going on. Efforts to integrate the information needed have revealed gaps in what we measure and how we track water diverted to fulfill water rights. A huge challenge is measuring water use. It is a challenge to sort out diversions, return flows, and consumptive use. It's a challenge to quantify irrigation and evapotranspiration from agriculture, and municipal and industrial water losses. It's a challenge to make sure that reductions in water use high in the basin intended to replenish the lake actually make it to the lake. I think that this is a problem that is bigger than just Utah or even the Colorado River Basin, and we need good measurement systems and more extensive, integrated, and easy-to-use data systems to manage the measurements. This is a specific case of the hydroinformatics challenge mentioned earlier. There is an irony here, because we live in a world of information overload. We are bombarded by information from many sources. The information science challenge is to collect, organize, and integrate data so that information is consistent, reliable, and trusted. Solutions here need to involve improved technology and shared solutions around the nation and world. The informatics needs of Utah are not dissimilar to those elsewhere. We need collaboration to improve, advance, and generalize hydrologic information systems. The Utah Water Research Laboratory also welcomes collaboration in any of the areas where we work. In the hydraulics laboratory, we have research ongoing on dams, spillways, canals, and upgrading of pipes, all part of aging infrastructure. In the environmental quality lab, we have work addressing multiple contamination challenges: PFAS, plastics, harmful algal blooms, and the instrumentation needed to measure and understand these. We have Aggie Air, a drone-based system for high-resolution remote sensing. Water resource work addresses conservation and river basin planning, reservoir operations, in-stream flows for habitat and water quality, including stream temperature. I hope this gives a bit of a glimpse into some of the collaboration opportunities offered by the Utah Water Research Laboratory.